We're on the bottom of page 7 of the review. We're looking at evaluating logarithms. And honestly, for these problems, you're going to definitely want to have the calculator handy because you're going to be using what we call the change of base formula. Okay, and you can do these directly on your calculator. It makes it really simple. The change of base formula, if you'll recall, so that you can input it in your calculator. The calculator only does a base of 10 and a base of e. So if you have log base b of a, you would do log base 10 of a divided by log base 10 of b. Or you can do natural log if you want to do natural log of a over the natural log of b. Okay, you put the argument on the top and the base on the bottom. So I'm going to pull my calculator up and we're going to look at these problems using that formula and my calculator. Okay, so I have log of 3 of 81. So if I'm looking at this problem, the B is my 3 and A is the argument, or 81. So I'm going to enter in my calculator log of 81 divide by log of 3. Okay, and I'm going to pull my calculator up. And we're going to type that in. So we press log of 81, close the parenthesis, divide log of 3, close the parenthesis, and enter. And it gives me a value automatically of 4. So log base 3 of 81, when you evaluate it using your calculator, it equals 4. Guys, don't overthink it. It honestly is that simple. Okay, so then we have log of 125, which would be your B, of 5, and so your A is 5. So we would have in our calculator log of 5 divided by the log of 125. Again, I'm going to pull my calculator up. We're going to type that in. So you would type log of 5, close the parentheses, divide log of 125, close the parentheses, and enter. Now it gives it to you in a decimal form. Remember, if you need it in fraction form, we press the button that says math and option 1 for fraction, and it'll convert it. And we get a value of 1/3. So log base 5 of 125 is 1/3. Moving on, again, we have evaluating them, log base 2 of 1/16. There are other ways to do these problems, but quite honestly, using the calculator is your best option. So log base 2 of 1/16, B here would be the 2, and 1/16 would be the A. So we would type the log of 1/16 divided by log of 2. Pull the calculator up. Okay, so you would type log 1 divide 16, close the parentheses, divide log 2, close the parenthesis, and enter. And we get a value of -4. Then the last one, or the supplemental, is log base 2 of 16. In this scenario, your B is 2 and your argument is 16. So we would have log of 16 divided by log of 2. Again, please use your calculator. It makes it so much simpler than trying to do it in your head. And a lot of these you can't do in your head. So log of 16, close the parenthesis, divide log of 2, close the parenthesis, and enter. And that gives us a value of 4. So log base 2 of 16 is 4. All right, moving on to the next section, which takes us to page 8, and laws of logarithms. And the first question asks us to write the expression log base 5 of x minus log base 5 of 7 as a single logarithm. So I noticed that this particular problem involves subtraction, and that subtraction is rewritten as division. So this would become log base 5 of x over 7. And that's your answer. Don't overthink it. Just apply the property. Subtraction is rewritten as division. Addition is typically rewritten as multiplication. So looking at question 2, we have 6 log base 9 of r plus 2 log base 9 of t. Now the first thing that jumps out at me about this problem is that we have these numbers in front of the logs. Remember, those were originally exponents using the power rule, and they get kind of tossed back up to the exponent position. So first we would have log base 9 of r to the 6th power plus log base 9 of t to the 2nd power. Then I note that the two logs are being added together. Addition is rewritten as multiplication. So we have log base 9 of r to the 6th times t to the 2nd. And that's it. And then one more supplemental question. It says write log base 3 of x plus 1 equals 5 in exponential form. So they want you to convert from the logarithmic form to the exponential form. And so if you'll remember, if you have log base b of your argument equal to x, that's rewritten as the base to the x power equals the argument. So for this problem, we would actually have 3 to the 5th equals x plus 1. That's the logarithm written in exponential form.